Good morning, everybody. Today we're going to be working with scale factor. And of course, we've already kind of dealt with scale factor in the past. We dealt with understanding if you have a figure, you can either make it larger or smaller by multiplying by a scale factor. So this is kind of like a retread. The only thing is now we're going to be able to see how the volume, area, and perimeter of a figure changes due to a scale factor, okay? So I'm first going to give you a little quick review of scale factor, and then we'll go into the change of dimension problems, okay? So here we go. So as you can see, this is 20.1 scale factor, okay? We have two more sections beyond this, and then everything else from then on will be just review of previous lessons, okay? So this is the new stuff, okay? So we have scale factor. Everybody should remember scale factor is the image divided by the pre-image, or the new image over the old image, okay? And of course, we know that if k, which is the scale factor, is bigger than 1, then it's an increase. And if we see if k is in between 0 and 1, it's a decrease. Okay, so here we have this very important chart that you see. Okay, it says the effects of changing dimensions proportionally. Okay, so as you see, it says change in dimensions. It says all dimensions multiplied by a. Okay, all right. It says change by a factor of a. So this is the perimeter and the circumference. Remember, perimeter deals with rectangles, squares, or triangles, anything that's a shape other than a circle. Circumference deals with only circles, okay? But the step that you must apply is the same. So if you want to check to see what the perimeter is becoming, whatever scale factor you have, you just multiply that by the old perimeter or circumference, and therefore you'll get the new perimeter or the circumference, okay? So this is pretty straightforward. And we also have area. Okay, so this is saying it changes by a factor of a squared, okay? So what does that mean? Just to give you an example, if your scale factor is 2, then your change will be 2 squared, which will be 4. So if you start with an area of 20 units squared, then if you multiply by 4, then you'll see that it will become 80 units squared, okay? All right, so that's basically how that makes sense. And because of what is 80 divided by 20? Well, it is what? 4. So therefore, you end up with your original scale factor after you started with your scale factor change, okay? So that's just kind of giving you an intro into what this is all about. So I'm going to give you some examples. Okay, so here we go. We have right here, it says find the area of the figure after having the dimensions. Having, what does having mean? It's similar to having, H-A-V-I-N-G, but it's also halving. It's meaning to cut in half, right? So half is 1 over 2, so that's pretty straightforward. And as you notice in all these questions, I have what I'm looking for in red, and what we're our scale factors in green. Okay, so that's good to know for the questions that are in the quizzes game. The scale factors in green, and the area, or excuse me, the what you're looking for is in red. Okay, so we know we're dealing with area. So if we go back to our other slide, area, we have to do a squared. Okay, so a squared. So what does that mean? 1/2 squared, what does that mean? That's saying 1/2 times 1/2. Okay? Well, when you multiply fractions, you multiply across. 1 times 1 is 1, and 2 times 2 is what? 4. So basically, what does this mean? This means that this is 1/4 of the old area, which is 8 times 8, which is 64. So 1/4 of 64 is what? 16 units. So it should dawn on you that if the number if this scale factor is less than 1 and greater than 0, which it is, then you're going to get a smaller area in this case. So you started with 64 because this was 64, right? It's 8 times 8, and then now you end up with 16, okay? Because when you divide that by 4, you get 16. Okay, so that just kind of gives you an example of one of them. Here's another example right here. Okay, it says a triangle's 3 sides are increased by a scale factor of 3/5. What is the result on the area of the new figure? Okay, so let me just underline area so that you see that's the key phrase, area. What is the result of the new What is the result of the area of the new figure? So they don't want to know the actual area. All they want to know is what happens to the area, okay? So there are a lot of questions like that in the game. So all you need to do is take your A, and what does this mean? 3/5 times 3/5, okay? So if I were to show you right here, so I'm going to erase that to kind of show you, 3/5 squared equals what? 3/5 times 3/5. Well, that will equal, well, what do? 3 times 3 and 5 times 5. That is what? 9/25. And that's my answer. So that meant that this is actually getting 9/25 fifths, or 9/25 smaller, okay? Because 9/25 is less than 1, okay? So that's what this is saying. The area of this triangle is getting smaller, okay? Okay, so we're done with area. So let's do one with perimeter. Okay, so if we see this, it says the dimensions of the triangle are dilated by a scale factor of 3. Okay, so they're saying what is the perimeter of the new figure in inches? Okay, so we know our scale factor is 3. And what are they looking for? Perimeter. So perimeter means what? Do we do a squared? No, we just multiply times a. Okay, so we know what perimeter means. That means we add up all the sides. Okay, so what's that? 12 plus 13 plus 5. That's equal to 30. And we know our scale factor was actually 4. So excuse me, that was a little mistake right there. The scale factor is actually 4. So what are we going to do? We're going to multiply 4 times 30, which is actually 120 inches, okay? So that's basic, okay? So whatever your scale factor is, you just multiply times what your perimeter is. And perimeter, you know, is the sum of all the sides, okay? So that's how we do that one. Okay, so we've done perimeter, we've done area of a rectangle, and we're going to do area of a circle, okay? All right, so now we say if the circle is dilated by a scale factor of 2 units, what would be the new area in centimeters squared? Okay, so you have this as 16 centimeters, okay? So that's our area. So what do we need to know? Our A is what? A is equal to 2. So we do 2 squared, which is 4, okay? Now we need to multiply 4 times the area. Well, we know the area already is 16, so 4 times 16 is 64 centimeters squared, okay? So that makes sense, okay? Because that's what our new area would be, okay? All right. So we're done with area of a 2-dimensional shape, or perimeter of a 2-dimensional shape. So now we're going to deal with 3 dimensions right now, okay? So here we go. All right, so this is the effects of changing dimension in 3 dimensions, okay? So right here we have this nice table that you should look at, okay? And right here it says all dimensions multiplied by A. So this is the change in dimensions, okay? So this is your surface area. Now everybody understands surface area is just area of a three-dimensional figure, the different surfaces added together, okay? So what happens with the surface area when you change by a scale factor? Well, a squared. So a becomes squared. So it still deals with area. So just like in the previous examples, area was what? Squared. All right, so you're going to square your a. You're going to square your scale factor. What about here? When it says changes by a factor of a cubed, that's for volume. So that's the only one that's cubed. Volume means you're going to do a cubed. So whatever your scale factor is, you're going to cube it. That means you multiply it by itself 3 times. And then you multiply your volume, or in this case, your surface area, by that new scale factor, okay? All right, so here's an example. All right, it says the volume of a cylinder is dilated by a scale factor of 2. What is the volume of the new cylinder in feet cubed? Okay, so right here you have your volume, right? You see your cylinder and it has the volume, right? It's 8 feet cubed. Okay, so what is our scale factor? Our scale factor is 2. As you can see, I have that in green, and I have what I'm looking for in red. Okay, so you differentiate and you kind of hone in on what you need to look for. Okay, so we got a equals 2. So then we say 2 cubed. What does 2 cubed mean? 2 cubed means to multiply 2 times 2 times 2, which gives you 8. Okay, so then what do you do with the 8? You multiply the 8 because it's a scale factor. You multiply the 8 times what the original volume was, which is 8, and 8 times 8 is 64 feet cubed. Okay, so that was dealing with volume. So now we're going to have one more example that deals with surface area. Okay. All right, so here you go. It says the surface area of a box is 2,700 meters squared. Find the surface area of a similar shaped box that is smaller by a scale factor of 1/3. So the key words right here: surface area, and then scale factor, and then smaller. Smaller is actually important too, because you know your answer needs to be what? Smaller. Okay, so 1/3 is our scale factor. So we got a equals 1/3. Well, what does 1/3 mean? 1/3 means 1. This actually means what? This means we're going to square it, and we're going to put 1/3 times 1/3, okay, which is you do 3 times 3 and 1 times 1, which is what? 1/9. Okay, so what do you do over here? 2,700 times 1/9 is like saying 2,700 divided by 9. So that's what you get right here, which is 300 meters squared. So your new surface area is 300 meters squared. Okay, so just to reiterate what we did today, we did the change in dimensions when we're having perimeter and area of a 2D shape. And you know, when it's the perimeter, it's just a multiplied by a. When it's the area, you have to square the a and then multiply it. Okay, and then of course, when you're having the change in dimensions of three-dimensional figures, what you do is, for when it's surface area, you multiply by a squared. So you have to take whatever scale factor they give you and then square it, then multiply by that surface area. And then for the volume, you do a cubed. So if they give you a scale factor of 4, then you need to do what? 4 times 4 times 4, which is actually 64, and that would be multiplied by the volume. Okay, so all these examples that I gave you today are pretty much just like the questions in the game. So I gave you about 5 or 6 examples. So basically those are the types of questions that you're going to see in the game. You're going to have 2 times to play. Okay, this assignment will be due tomorrow around 6 or 7 o'clock p.m. Okay, so of course, take your time. I suggest you pause the video and do your very best, okay? Everyone stay safe, and I'm signing off.